Hi children, in the last class we discussed about magnetic field and magnetic field lines, and we also discussed the properties of magnetic field lines. Okay, do you studied it well? In this class we are discussing about magnetic field due to a current carrying conductor. We know the magnetic field due to a current carrying conductor has a magnetic field. That's we already discussed in the previous class that when I bring a magnetic compass near the electric current carrying conductor, the magnetic compass deflects. This is due to, what is the reason for this? That is, the electric current carrying conductor acts as a small magnet. Okay. Then now we are discussing about the magnetic field of different shape. That is, different shape means first we will discuss about a straight conductor or straight wire. How will be the magnetic field of a straight conductor or straight wire. Then we will bend the straight wire into circular loop, and at that time we will discuss the magnetic field. How will be the magnetic field of a circular loop. Then we will discuss about how will be the magnetic field of a solenoid. Okay, so first we start with the magnetic field due to a current carrying through straight conductor. Here we are drawing a circuit. This is the rheostat and a ammeter is there and battery. Okay. Then the key. Okay. The current flows from positive to negative. That is like this. Okay. Here this is a straight wire. Okay. Here it is a straight wire. Then in the magnet we know this is, suppose this is a magnet, north pole and south pole, and in the magnet it is the magnetic field, the shape of the magnetic field is like this. Okay, we discussed it in the last class. In a magnet, the magnetic field of bar magnet is like this. Then how will be the magnetic field of a straight wire? This is a straight wire. Okay, then in the straight wire I am drawing a plane like this. Okay, this is a plane perpendicular to this straight wire, and the magnetic field, the shape of the magnetic field will be like this. Okay, that is, many concentric circles combine to form the magnetic field of this straight wire. That is, in a straight conductor, the magnetic field is represented by the circles, concentric circles. Okay, which become, first it is smaller, then become larger, then become larger, larger and larger. This is the magnetic field of a straight conductor. The magnetic field of a straight conductor is represented like this. That is, we draw a plane in a perpendicular plane, and in this plane we draw some concentric circle, and this concentric circle is the magnetic field. A magnetic field is represented by the concentric circles which become larger and larger. The concentric circles, these concentric circles representing the magnetic field. Okay, these concentric circles represents the magnetic field. These are magnetic field around a current carrying straight wire. Okay, then it become larger and larger as we move away from this wire. As we move away from this wire, this circle become larger and larger. As we move away from this straight conductor, the magnitude of magnetic field decreases. That means the magnetic field produced will be decreases. As the distance from it increases, the magnetic field produced by a current carrying conductor decreases. Hope you understand this. And there is another point, that is, as the current through the wire increases, when we increase the current through this wire, the magnetic field produced also increases. So what are the factors that increases the magnetic field? That means the magnetic field becomes stronger when more current flows through this. That is, as the current increases, the magnetic field produced increases. And another factor is, as the distance from this increases, the magnetic field produced by a given current in the conductor also decreases. Okay, these are the 2 points. So in a straight conductor, these concentric circles represents the magnetic field. Magnetic field of the straight conductor is these concentric circles, and these concentric circles, the strength, as we move away from this point, the concentric circles become larger and larger, and as the current through this wire increases, the magnetic field produced also increases, and also as the distance increases, the magnetic field produced decreases. Hope you understand this all. Then we can find the direction of this magnetic field. I already told you this magnetic field has a direction, and as current passes, when current passes through this, magnetic field is a vector quantity. So here also this magnetic field has a direction. Then how can we find the direction of this magnetic field? Okay, there is a rule for this, and that rule is called right hand thumb rule. Right hand thumb rule gives the direction of a magnetic field. Suppose this is a straight conductor, and the battery is there, and the rheostat is this, ammeter is this, okay. This is a straight conductor. Okay, the current passes through this straight conductor in this direction. This is the magnetic field. The magnetic field of this wire will be like this. Okay, we already discussed it here. Then the current passes in this direction. Then what will be the direction of these field lines? That is, the direction of these field lines can be found by using our right hand thumb rule. That is, we take our right hand and we straighten our thumb. Imagine that you are holding a current carrying straight conductor in your right hand. Right hand represents the current carrying straight conductor. My thumb represents the direction of current, and my folded fingers represents the direction of field lines. That means here the direction of current is in this side, and my hand is like this, my right hand is like this. So the direction will be in this direction. That the current flows in this side, and the direction of my field line folded fingers is like this, that is like this. Okay, and the current flows, this is a straight conductor, and the current flows through this in this direction. The I current flows through this. What is the direction of this magnetic field lines? This is the direction of electric current, and the folded fingers is in this direction. Okay, the folded fingers is in this direction, therefore it will be in this side. Okay, hope you understand this. According to the right hand thumb rule, when the current flows in this direction, the magnetic field lines like this. The direction of magnetic field lines is like this. When the current flows in upward direction, the direction of magnetic field lines is like this. That is, what is right hand thumb rule? Imagine that you are holding a current carrying conductor in your right hand such that the thumb points towards the direction of current, and then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field. This is known as right hand thumb rule. Okay, this is the right hand thumb rule. Hope you understand this. Here we discussed the magnetic field due to a current through a straight conductor, and the direction of magnetic field due to a current through a straight conductor is given by right hand thumb rule. According to right hand thumb rule, the thumb points towards the direction of current, and then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field. This is known as right hand thumb rule. Hope you understand this. Here we are discussing the magnetic field of conductors. Conductors of different shapes. Shape of the magnetic field depends upon the shape of the conductor. Okay, here conductors are of different shapes. The shape of the magnetic field depends upon the shape of the conductor. Let's see the different shapes of conductors. They are straight wire, circular loop, and finally the solenoid. Okay, first we already discussed the magnetic field of straight wire, or the magnetic field of current carrying conductor through a straight wire. Okay. When current flows through the straight wire, the magnetic field will be the concentric circles centered the wire. As we move away from the wire, the concentric circles become larger and larger. Then we are discussing about the magnetic field due to a current through a circular loop, or simply we can say magnetic field of a circular loop. Take a straight wire and bend it into a circle like this. Okay. Now when you pass current through the wire, it produces a magnetic field. When current flows through the wire, a magnetic field is produced around the wire. Magnetic field of a circular loop is stronger than that of a straight wire. To understand the magnetic field of a circular loop, these magnetic field lines are circular near the wire. As we move away from the wire, these concentric circles become larger and larger. These concentric circles represent the magnetic field of a circular loop. Okay. At the center of the circular loop, the magnetic field becomes a straight line. By the time we reach at the center of the circular loop, the magnetic field lines appears as a straight line. Then how can we find the direction of magnetic field lines? What is the direction of magnetic field lines of a circular loop? For a straight wire, we find the direction using right hand thumb rule. Similarly, here also we find the direction of magnetic field lines of a circular loop using the right hand thumb rule. By right hand thumb rule, the thumb aligns at the direction of current. Then the folded fingers gives the direction of magnetic field. As you can see, the magnetic field lines of circular loop have the same direction at the center of the loop. At the center of the circular loop, it has same direction. So, all the magnetic field lines will add up at the center of loop, and the magnetic field become stronger at the center of the loop. Then, How can we increase the strength of magnetic field? How? First, by increasing the amount of electric current. When the amount of electric current through the circular loop increases, the magnetic field produced also increases. That is, the strength of magnetic field can be increased by increasing the amount of current. And the another factor is the distance. As we move away from the circular loop, the magnetic field produced will decreases. That is, as distance increases, the strength of magnetic field also decreases. As the distance increases, the strength of magnetic field decreases. Now, instead of one circular loop, there are 5 circular loops. Then what will happen to the magnetic field? Is it increases or decreases? Yes, the magnetic field becomes stronger. That is, when the number of circular loops increases, the strength of magnetic field also increases. More magnetic field is produced when we increase the number of circular loops. Then, what are the factors strengthen the magnetic field? That is, by increasing the current, by increasing the number of circular loop, and by decreasing the distance also. Just like the coin has one side head and the other side tail, the one side of circular loop is north pole and the other side of the circular loop is south pole. Which side of the circular loop is north pole and which side of the circular loop is south pole? How can we identify this? When you are looking at the face of the circular loop and the current flowing in the clockwise direction, the current flowing in the clockwise direction as shown here, then it is the south pole. When the current flowing in the clockwise direction, then the side of the face of the circular loop is the south pole. And when the current flows in anti-clockwise direction, when the current flows in anti-clockwise direction, then the face of circular loop is north pole. Okay, hope you understand. That is, when the current flows in clockwise direction, it is south pole, and in anti-clockwise direction, it is north pole. There is an easy way to remember this. That is, the word anti-clockwise has the letter N in it. So, it is the north pole, and clockwise direction will be the opposite pole. Then it is the south pole. That's all about the magnetic field due to a current through circular loop. In this class, we discussed about magnetic field due to a current carrying straight wire and the current carrying circular loop. In the next class, we will discuss about the solenoid magnetic field due to a current carrying solenoid. Okay, we will continue in the next class. Thank you.